All right, so today we want to factor. And what factor means is to write something as multiplication. So we want to take things and write them in multiplication form. So for example, if you have the number 10, you can write it as 5 times 2. Now, that's not really helpful to write the number 10 as 5 times 2. But just yesterday, we took numbers, or we took expressions like, say, x plus 4 times x plus 2. And when we multiplied it out, we got x squared plus 6x plus 8. So sometimes taking an algebraic expression like x squared plus 6x plus 8 and rewriting it as multiplication or in factored form, sometimes it's very helpful. Today we're going to talk about the basic examples of factoring, and it will get more difficult as time goes on. We're going to factor greatest common factor, we're going to factor difference of squares, and we're going to factor trinomials. You need notes? Okay. Greatest common factor. Always the first and most important element to factoring. We look at the 10x and we look at the 18. What are 10 and 18 both divisible by? 2. Do they both have an x? No. So we just take out 2. The question that we now ask is 2 times what is 10x? 5x. 2 times what is 18? So the nice thing about factoring is you can always check your answer. If you multiply it back out, you should get what you started with. 12, 2, and 6 are all divisible by. And they all have how many x's? So I take out the x squared. 2x squared times what is 12x to the 4th? 6x squared. 2x squared times what is 2x cubed? X. And 2x squared times what is negative 6x squared? It's minus 3. What you teach? Number 3, what do we take out? X cubed and y cubed are different. They are unlike terms. If you take out the 2, you get 2x cubed. What happens to the 2 in the middle? Very good. This is very important. Watch, folks. This is the mistake that people make. 2 times 2x cubed is 4x cubed. 2 times what gives you 2? 2 times what is 6x cubed? Or 3y cubed. Thank you. So the mistake that people make is when they factor out the 2, they feel like it just disappears. It doesn't just disappear because 2 times 1 is the 2. That's what you have to do. Okay? Skip example 4. Flip it over. Okay, good. Sometimes you get more complicated numbers. 80 and 48. What do you think both of those are divisible by? 8. They are. I will factor out the 8, and I'll also factor out 16. X. You're right. 16 is, but nobody said that, so I'm going to show you. Okay, so I'll get to it in a second. If I factor out the 8x, what remains? 10y minus 6x, or just 6. So now as you look at it, is there a common factor among 10 and 6? 2. So we factor a 2 out, that 8 would turn to 16. We factor that 2, it would be 5y minus 3. So if you don't catch a 16 right away, you can factor multiple times and see what you get. What's different about number 6? We say that if there's a negative in front, you should factor out the negative as well. So if you factor out a negative 5d times what is negative 5d squared? Just d. If you factor a negative out of 15d, negative 3. That's the common factoring. Let's look at the trinomials. These are trinomials, and trinomials often factor to two binomials. What do you multiply to get x squared? X and x, very good. Now, you can look at this last number. What two numbers multiply to negative 15 but add to positive 2?
3. Positive 5, negative 3. Okay, but he just has the number.
Very good. Okay. X and x, what two numbers multiply to 5 but add to 6? Can you see how sometimes people use 2 and 3? No. We make mistakes. So you can see how 2 and 3 is sometimes what people think, but in fact it's 5 and 1 in that situation. Two numbers that multiply to 12 but add a negative 7. Negative 4, negative 3. So when it's positive like that, you can have two positives or you can have two negatives. It looks like two negatives because they're going to add to a negative number. X and x. Then what? Minus 8, minus 4. You try 11 and 12 on your own. Go. 14. All right, so you have x plus 8 times x plus 8. If you have something multiplied by itself, you can write it instead as x plus 8 squared. So let's just be clear. On the test, I'd like you to see I'd like to see you write as x plus 8. But if you don't write as x plus 8 squared, if you write as x plus 8 times x plus 8, I'll still give you full credit. But I would like to see x plus 8 squared. No, not x. I don't believe in extra credit. I don't believe you will either. I'll give you the answer right after we do this. No, we got it. Right after we do these. What's different about the next set? So I accidentally didn't put a space. X squared minus 1. I know. My mistake.
Dude, it looks like a decimal. You got it.
So here's what's really cool about these. It's the same thing as a trinomial. The difference is that the middle term is a 0x. The middle term is a 0x. So notice that when I multiply these out, I have x times x. What are the two numbers that multiply to negative 1 but add to 0? Positive 1 and minus 1. And that's why the difference of two squares is so beautiful. You just take the square root of both and put a plus and a minus. So x squared minus 9. Those are both perfect squares. Plus 3 and minus 3. Uh-oh, we got a big number. Yup. X times x is x squared. We got a minus 14 and we got plus 14. What's different about example 16? What multiplies to 4x squared? 2x and 2x. What multiplies to 81? 9 and 9. So I got a plus and I got a minus. I'm going to skip 17 for a second. I'm going to roll over to 18. What do you multiply by itself to get x squared, y squared? xy, xy. What do you multiply by itself to get 4? 2 and 2, good. Positive and a negative. I like the way you roll. Now, the reason why I saved 17 is because this is a little bit of a problem here. And the problem is that when we factor this, you should always start by taking out a greatest common factor. Does anybody know what divides evenly into both 100 and 36? 4. So let's take out that 4. If you take out 4, what are you left with? 25x to the fourth minus 9. Is 25x to the fourth and 9, are those both perfect squares? Yes. So they will factor to the following. 5x squared and 5x squared, and then what? Plus 3 minus 3. So that brings us to our last set, which is factoring completely. Sorry about the decimals. We're going to skip 24 altogether, but we're going to look at these others. I'm going to do a couple with you, and then you're going to try some on your own.
Oh, wait, yeah, you have to tell us why.
I will after we get through this set.
You said that last time.
No, trust me, let's just do this. I'll tell you a story. Promise. Okay,
You promised.
I promise. Okay, factor completely. You always start by taking out the greatest common factor. Take out the 2. We take out 2, you're left with x squared plus 5x plus 6. Does that remaining trinomial factor to what? Good. If you look at the next one, what's the common factor you can take out? If you take out 3, what's left? Great. Does x squared minus 25 factor? To what? I'll do one more, then you'll do the last 4 here, okay? What's the common factor in this problem? Take out the x, you've got x squared plus 2x minus 15. Two numbers that multiply negative 15 that add to 2. Be a plus 5 and a minus 3. Yep, good job. So I want you to do the ones that are left right here. There's 4 of them. When you get them, come and put them up on the board. Yeah, you guys participate. Oh, there's 5 of them. Look at that. 1, 2, 3, 4, 5. Let's get 5 different people to come up here and put an answer on the board so you can see how we did it, okay? Okay? Later, dude. You missed my story. Factor out of 2. What are you left with? X squared minus 49. 49 is a perfect square, so I got x minus 7, x plus 7. Last one, we factor out an 8x to the what? 5th. You're left with x squared. Oh, sorry. X squared minus 4. And that does factor. X minus 2, x plus 2. That's that. Right?